Ladies and gentlemen, we have another amazing session planned for you. So the next session is going to be on Google BigQuery, Heart of Smart Analytics toolset on Google Cloud. We are privileged to have Mr. Vijaykumar Jangamashetti, a trusted advisor, a Google Cloud consulting architect at Google. Joining us today, let's give a warm welcome to Vijaykumar Jangamashetti, sir.
So a word about Vijay sir. He has an extensive experience in data analytics world. We are excited to learn about Google BigQuery and how it empowers organizations to drive limitless innovation when it is fully managed. Before we move on to session, I just want you all just to know that we have something excited lined up for you after this session. So just can't wait for that. Over to you, sir.
Thank you. Good afternoon. Exactly, it's noon. Good afternoon. Great, fantastic. So thanks, the organizers. It's great, doing great today, and thanks to lovely cloud enthusiasts as well. So as you know, my name is Vijay, and I'm a cloud consulting architect at Google and specialized in data and analytics. Okay, so when it comes to data analytics, I saw like we covered database and also some compute and then into AI. So at that time I was just, when my other colleague just raised a show of hands, so it was like Vertex AI, anyone know? Then BigQuery. I'm very happy that I saw a lot of hands on BigQuery. I don't want to do it again, but I already saw the result. I'm pretty happy. And coming to the data versus other part of the cloud. So data folks can just show their hands. Data, it can be database, data management, data analytics, and it can be ETL. Yeah, fantastic. Yeah. So let's see how BigQuery say like heart of smart analytics toolset. Yeah. Okay, so we are pretty happy to work with pretty customers, partners to drive the limitless innovation, which is like open, unified, and intelligent data ecosystem. So this is what the data mission of Google Cloud. This is an innovation journey of Google Cloud, right? So it started in 2002 with a GFS, and then MapReduce is like, Google is the one who started big, Hadoop? Hello? Yeah. So it's the one who started that, right? The Hadoop ecosystem and other things. Then this is how the journey started. Then 2006, Bigtable, then Dremel, right? It's like a executing engine for Google Cloud, and then Colossus. I think we just in the database session we went into what Colossus is, right? So that's a columnar storage what we have everywhere across. Then Flume and Spanner, what we across was like horizontally scalable database, right? And then we have all the PubSub, Dataflow, TensorFlow. I think that's what we are here, and we do have a lot of inventions going on as well. So when we say what is Google BigQuery, so we have few uniqueness things about Google BigQuery. So it's like fully managed and serverless, which we get maximum agility and scalability as well, right? And then no need to do any kind of a spinning your cluster or any kind of VM behind it, but BigQuery does it for all, okay? And this is which can scale from gigabyte to petabyte scale storage with SQL queries, okay? And we will have a quick demo on the petabyte scale, how it works. And it's encrypted, durable, and highly available. So it's like BigQuery have a capability of doing encryption, right? So you might know about encryption. It can be encryption at rest, encryption in transit, and also on top of that we have a feature called as customer managed encryption keys, which is like a next level of security. Okay, and the best thing is we can have a real-time insights from the streaming data. So BigQuery have a capability to get the data extracted with the help real-time. And then the best feature, I'll have a small demo of that as well, is built-in ML, which is out of box. Okay, and this, by just writing a simple SQL queries, you can create a model, train a model, and predict, right? So it's called as BigQuery ML, right? So we'll go through that as well. And we have other feature of high-speed in-memory BI engine, which will help for faster reporting and analysis. Okay, so let's get into that. So why we call it's most advanced serverless, right? So we don't need to bother about scalability of compute and storage. If you see a diagram over there, like traditional big data analytics, so analysis and insights is a main motto of our warehouse tool, right? But if you see on traditional big data analytics, we have to take care of everything, right? Resource provisioning, and then handling reliability, deployment, utilization, performance tuning, and monitoring. But if you see BigQuery, which is like serverless data analytics, so I think everything being taken care of the back end from BigQuery. Okay, so with this, I think we have a other feature of multi-zonal replication as well. So whenever there is kind of a failover and DR and all, we don't need to worry. So the data is always replicated into multiple zones, right? And then, as I just told, that there's no any requirement of any software upgrades or any kind of a security upgrades. And the best part is BigQuery gives you like 99.99 SLA, that's 4 nines, okay? So now come to the best part of BigQuery. This is one of the reasons why we call it as BigQuery as the heart of smart analytics toolset, and BigQuery is very close to my heart as well, right? So we say it interacts with all the four types of applications. It can be analytics, visualizations, applications, and predictions, right? So analytics, it can be a data warehouse, data lake, and then BI, we have a Looker, and other third-party dashboarding tools as well, so where we can interact with that. And then internally, it can talk with Spanner and other relational database, non-relational databases as well. And then when it comes to predictions, yes. So we do have a BigQuery ML as well, and also interactions with collaboration with Vertex AI as well. So where we can get all the predictions with the help of BigQuery. So that's what BigQuery sits at the center, and that's the reason it's like a heart of it. So let's get into architecture. I think Preetham covered a bit of them, why we are covering storage and compute at a separate one, and it can be easily highly scalable. So when we have a different storage and compute, this makes the architecture pretty unique, okay? So which has a capability to scale independently and which is connected by a petabit network, right? And we have a query execution engine as well. And if you see on your left side, so these are the different types, like how can we get the different ingestions, like it can be a batch ingestion, it can be a streaming ingestion, and we can have a federated queries running from Google Cloud Storage, and also we have a high throughput storage access as well, right? So I think we have data, right? And with data, I think we need to analyze that, right? So just having data doesn't make sense. We have to utilize, visualize, get the data insights out of it. So that's why we have different libraries, APIs, which will connect to a third-party BI tools, and also our inbuilt Looker. And the best part of writing a SQL query is just it is ANSI SQL 2011 compliant. So we can write easy queries, create tables, insert, and like DDL, DML, and then also ML, right? And then we have two methods to reach out to BigQuery, right? How to communicate. One is web UI, another one is on the CLI, okay? And then we have plenty of APIs connecting BigQuery to the external world. And also we have JDBC, ODBC drivers. So this is how, with this architecture, gets BigQuery a de facto performance, right? And you might know like how the difference between the traditional RDBMS and a BigQuery columnar storage. So anyone can give example of traditional RDBMS? You can shout out. SQL Server, yeah, Oracle. Be louder. MySQL, right? I think, yeah, these are few traditional RDBMS storages, so it happens at a row level, okay? But in BigQuery, as we have architecture built in a such a way that the BigQuery data is stored in a columnar storage, which really gets the performance to get the data retrieved as well. Okay, so again, how the data is stored, right? It's stored in the optimized columnar format, but it's stored in the compressed format into different disks. So if you see the table being replicated into different zones, zone A, zone B, zone C within a region, right? In case of any kind of a disaster recovery or any failure happens, I think we have data safe, right? So this is how the BigQuery is stored in the backend. And if you see this slide, right, this is a query which is running of 1 TB of compressed data, and when it is like a 4 TB, it's when it decompresses it. So this is executing 100 billion regular expressions, right? And it's distributing 1.25 terabytes of data across the network. If you see the query, it is just running, and this is a running query with, it's less than 20 seconds. If you see that the query is running, it's just a select query. What we are doing, it's less than 30 seconds. So this query is completed 24.7 seconds, where 4 TB has been processed. So this is how BigQuery, we call it as a speed matters, and BigQuery is fast, right? So I'll show you a few demos over there as well. So at the other slide, which tells BigQuery is the heart of Smart Analytics toolset. So if you see a red icon, BigQuery icon is in each and every phase of our data lifecycle, right? So BigQuery can help to get the data ingested along with the other tools, right? I can just bit and pieces. I can just say ingestion, PubSub, Cloud IoT Core, and then data transfer service as well. And the processing, right? So we have a data flow, data proc. We can do a data processing into the BigQuery, right? And then storage, yes, we have a BigQuery storage. And then we have data warehousing for doing analytics. And also these are used into like Looker Studio, Looker, and then taken ahead into the Sheets and Cloud AI services as well. So if you see the other things as well, so like Data Fusion, Composer for orchestrating, right? So this is how BigQuery sits into the analytical toolset of Google Cloud, right? And BigQuery also helps to democratize the data insights, right? It can be by just saving the query or sharing it to the wide level queries. You want to reuse the queries across your projects, across your teams, and then getting the beautiful visual insights done with the help of Looker Studio, right? Which is like connected, and then we have Sheets, and then we have a third-party partner tools as well. So which will help to BigQuery to democratize its data insights to the external world. So this is another quick demo what I just want to show you, the BigQuery ML, right? It's just in 2 steps. If you see a query, it's create model, okay? And then with this model, it's just creating a model at the back end, okay? And then it's done, and then getting into a prediction. It's again a simple SQL query to predict the number of trips for that trip date, and this is the result what we get it. So this is how pretty easy to run your BigQuery ML with the help of simple SQL statements, right? So, and we don't need to bother about any infrastructure, management, security, and any compliance associated with that. So that's the one. And then coming back to wider spectrum of BigQuery. So I think what all continuous innovation have done by Google with respect to BigQuery and other data folks. Like the one is BigQuery Omni. I think anyone heard about Omni? I think these days, I think it has become Anthos, Omni. This is the one which connects to various other cloud providers and also on-premises. So where we can connect the data and get into you want to visualize the data within BigQuery from federating data from the other cloud providers or on-premises. This is a feature what BigQuery supports. And we have a geospatial analytics where we can analyze the data types of latitude, longitude, and others. And also stream analytics where we can get the data ingested with a streaming data, and then we just went to BigQuery ML, right? And other one is the analytics hub. I think that's a new one what we have come up as well. So it's like where we can get where we can exchange the value data and then analyze assets securely and efficiently. It's getting into a single view of everything where we can get the data sets and databases as well, right? And then the BI engine which we went is like a in-memory SQL analytics code. Another one is on Big Lake, right, where we are unifying all the data warehouses and data lakes, and then log analytics to get the data insights and get the data insights from the logs, and which will help to do a cost utilization, cost optimization as well. And beyond SQL, I think we can integrate with Node.js, Python, Go, Java, and other PHP functions in BigQuery. Okay, so I think some quick questions. So can we install BigQuery on our own managed hosting environment? No, yes? No, yeah. Because this is serverless and it's been hosted into Google Cloud's environment, right? And then do you get your own dedicated machines running BigQuery? No. Because it's all serverless. We don't need to bother about the machines at all, right? Can we perform machine learning on BigQuery? Yes, very good. Can we perform the data insights from BigQuery? Yes, perfect. I think that's good. So let's quickly touch upon the cost. Okay, I'll just, this is a new feature what we have come up with, like giving a flexibility and predictability to the customers, right? So I think we are hearing from customers like, okay, we have to give more flexibility as pay as you go, right? So this is what we come up with the different models as such, okay? So we don't need to over provision these slots. I think slot is the compute unit, what we call it in BigQuery, right? And we don't compare with the CPU, RAM, other things, right? And then we have to control the spend of the customers depending upon the workload requirements, right? I think I just don't want to go in deeper side because these are different things. Like one is on demand, which is still there. Earlier we used to get fixed slots and on demand. Now we have 3 different editions. So depending upon the usage, you can buy standard, enterprise plus. I think that's the different thing. And the best part of this is auto scaling. Okay, if you see the BigQuery dynamically adjusts the increase in the capacity and automatically allocates the cost, allocate the slots. Right. If you see a blue utilization graph, what it shows is, so whenever, for example, I have a slot of like 5,000, which I have bought it, but I have given a minimum as 3,000, maximum as 5,000, right? So I'll be paying for 3,000, but whenever there is an increase in capacity, it reaches 5,000 or it may be 4,000, but I'll be paying only for that cost. The customer will be paying only for that cost. Again, when the workloads decrease, right, when there is no increase in the capacity, it will come down, and again you will be paying, the customer will be paying only what number of slots being used. Right? So I think if you compare with other things, like it's like a warehouse has been started, we have to pay a full bulk of amount of, once you add the warehouse, add the compute and other things. So that's how we have to pay for it. So I think other, like we covered it, like we have a batch ingestion and streaming ingestion, and then we have a data transfer service which is inbuilt, which can connect with you to external world. For example, it can be Teradata. So where we have a DTS, data transfer service from Teradata to BigQuery, that's a widely used in the industry right now. And these are different formats of data, what BigQuery can ingest, right? Start with slower, JSON, CSV, and then we have Parquet, and then Avro. Avro is considered as the fastest mode of ingestion, what we can do. And the other one is on ETL and ELT, right? So what is a better solution, right? So anyone have worked on any ETL tools? Can name few? ETL? Informatica, great. Ab initio, fantastic. Data stage, yes, fantastic. So I think these are a few ETLs, but why we prefer ELT on BigQuery, right? So we have to prefer ELT over ETL. The reason because get the data into BigQuery first. For example, you have multiple sources what you have from multiple sources from different applications. So you have to get the data first into BigQuery. Then you can become an authorized distributor of data, right? At that time, you load the data and then you transform depending upon your business logic, right? Whatever it's that required. So I think the best practices, I'll go with the partitioning, and then I think the worst thing is, I think from today onwards, just take a vote, like we'll not use select star, because that is the one a bad query which will run. We are running from a long time, okay? But I think it will read out whole table, but for BigQuery, that's the charge it reads. It does a table scan if you put a select star, because it's a columnar data. So instead of that, if we properly use the columns, okay, and then giving the event date as for example, as a partitioning. I think everyone knows partitioning. So this improves the performance. And the next step is on the clustering, okay. And then if you want to take a next step ahead of partitioning, then we can get into a clustering, okay. And then we have one important thing about Google Cloud. I think someone would have deleted the data from the database in your previous world, right? So at that time, but Google Cloud BigQuery supports that. So we have a time travel. You can go back for 7 days and get the data back, right? So that's a best part what we can travel up, okay? And then I'll just quickly get into a demo. I think I have just two minutes on that. Okay, I'll just zoom it. So I'll just show you the petabyte. I think this is how the BigQuery looks like, where we have all the data sets, tables, and queries. Okay, so I'll just, so this is a query, what it is running. Okay, so this is a query of a retail, okay, let me come back to this. So, yeah. So this is like a retail data set which have like customer table, 4 million customer tables, and sales table is having 1 trillion rows, which is like worth of 1 petabytes, right? So I'm running a query. I was about to run a query for this one. If you see, just see here. The best part of Google BigQuery is it will tell, before you run this, so it will tell you this will process 1.09 petabytes when run. So if you see the query, right, so is it a good query or a bad query? Yeah, because it's a select star, right? So next step, if you would like to do a sales, find out a sales for that particular customer for that day, right? I've selected a column, okay? And then if you just see this, I'm not running query anyhow because it is showing straight away from 1 petabytes to it is reduced to 31.93 terabytes, right? So how this helps. And if you take a next step with partitioning, I think partition I just covered pretty fast. Okay, so if you covered with the partitioning, right? So this might, any guesses like how much data can be retrieved? With this, I'll just show you the query. Yeah, this again, I'm just doing it for that particular month. To say sales for that particular month from the sales table. Okay, so it has like trillions of rows. So this will get us like 265 gigs, right? 1 petabyte to 31 terabytes, and then it has reached to 265. Still, we have a place what we can do. Okay, and then other one was. A quick one on getting easy data insights into a BigQuery, from BigQuery, right? I can just, with a single click, if you run a query, see I have just not used select star, I've just used some selected columns. With a single click, if you just click on explore data, so with a single click, the data is going out for Looker Studio, and we can build. So we have a different Looker's offerings as well. This is Looker Studio, Looker Core, Looker Pro, right? So this is, again, this is a free of cost, what we get it for every customer, everyone individual as well. So just I want to just create a thing. Yeah, you see here, you see like different visa types. We have got 326 customer with it, and I just want to do a change in chart, so which will get this. And if you want to get this chart configured for different car types, we can play around with it. So if you see this, okay, platinum. So we have got a 682, which is the 34% platinum, and then 33% classic, and other one is gold. Right? And with this, I think we can definitely build beautiful reports out of it, and which is coming vanilla from BigQuery. So that's how what we call it. Okay, I think that was it for me. And any queries? I think I'm around. We can reach out offline, online as well. And yeah, thank you. Thanks for hearing. I think we don't have time for questions. Thank you.
Thank you so much, Vijaykumar sir, for enlightening session on Google BigQuery. Your insights into how BigQuery empowers organization to drive innovation through an open, unified, and intelligent data ecosystem were truly valuable. We appreciate your expertise in assisting customers in designing and architecting the data warehouses on Google Cloud.
On behalf of our team, I would like to express our gratitude to Vijay sir for sharing his knowledge and expertise with us today. Sir, I personally connected with your session because I am working in the field, so it was a great learning for me, I would say, and of course for the audience. To felicitate Vijay sir, I would like to have Dr. Sri Bhagwat on the stage.